So here's a question to test your observation skills. What's the difference? What's the difference between my appearance now and my appearance that was about, I don't know, 10 minutes ago when I was reviewing question 10? If you said these glasses, you're wrong. You're very wrong. If you said the part in my hair, you're correct. I changed sides. See, look, I can change all different sides. I'm a shapeshifter. I can change my appearance so now I'm totally unrecognizable. Or I can change it like this and I become an entirely different, this way. Yes. An entirely different person. Pretty cool, but irrelevant to math. Let's get cracking. Number 21. Students in an algebra class recorded lengths of a stretched spring as shown in the table below. Write an equation that describes the relationship between distance stretched and the weight of the screen. Okay. Well, we can easily do this algebraically, but we can do it even easier on the calculator. What a great tool. I wish they had these when I took algebra. How did I ever learn algebra without the calculator? Let's see here. We'll clear our lists here. Alright, and let's put in our info. 0, 2, 4, 7, 9, 10. Oops, not 19, 10. Let's put in this side 0, 1, or 0, 10, 20, 30. Oops, that's 35, 35, 45, 50. Okay. And I'm just going to graph that on our stat plot. I'll hit zoom stat. Okay, looks like it's a linear relation. So let's hit stat, go over to calc, calculate the linreg, and there you have it. It's y equals 5x, and you can easily see that because when x is 0, we're at starting point 0. When x is 2, we're at 10, so 2 times 5. 2 times 5 equals 10. 4 times 5 equals 20. 7 times 5 equals 35, and so on. So the relationship is the weight is equal to 5 times x, 5 times the distance stretched. And there you have it. That's a very simple relationship. Our starting point is 0, so the full equation, you could, if you want to see it all expanded, looks like this, 5x plus 0. What are the intercepts of 3x plus 4y equals 24? Okay, so we're talking intercepts here. We're talking about when our line intercepts the y-axis, the x-axis and the y-axis. So we know that, let's label these, x-axis, y-axis. So we know that when a line intercepts the x-axis, that the y value here is equal to 0. And we know that when the line intercepts the y-axis, that the x value here is equal to 0. So we use this information to find our x and y intercepts. So our y-intercept here, x is 0, so 0 comma question mark. And our x-intercept is when y equals 0. So we don't know what the x is, but we do know that y is equal to 0. So let's plug these in. So when x equals 0, y equals 6. When y equals 0, x equals 8. We can also take a look at this a different way. If you want to solve for y, then let's take 3x and move it over to the other side by subtracting 3x. So 4y equals 24 minus 3x. Let's divide every single term by 4 to isolate y. We can go y equals negative 3/4 x plus 6. So that's our equation, negative 3/4 x plus 6. And let's figure out, we can actually take a look at the graph there. So negative, let's come up here. So negative 3/4 x plus, don't want to do that, plus 6. And I'm going to turn that plot off by putting my cursor on it and hitting enter. And I'm going to zoom back to standard zoom, so 6. And there's our y-intercept. There's our line. So there's a y-intercept there, there's a y-intercept there. And so let's see if we can get a close look right here. And if we trace along that line, y equals 0, x basically equals 8. And we can actually, if you want, you can even go calculate 0. Left bound to the left of the 0, we hit enter. To the right of the 0, we hit enter. And the calculator automatically calculates that x equals 8 when y equals 0. So that would be the x-intercept. If we come back out zoom standard, we can easily figure out what y equals when x equals 0 by just pressing 0. So x equals 0, hit enter, y equals 6. So that's how, using the calculator and a little bit of algebra down here, you can figure out the x and y intercepts. So I just showed you 2 ways to find the x and y intercepts.